Hello, in this video we are going to talk about handling exceptions. The objectives for this video are to learn about exceptions in general, the exception class, and what happens when an application generates system exceptions. We're going to learn the syntax of using the try, catch, and finally keywords. We're going to use the exception class's ToString method and message property to help us show the user more information about the error that they encountered. And we will talk about how you can catch multiple exceptions and multiple types of exceptions. An exception is any error condition or unexpected behavior that occurs in an executing program during runtime. It happens by errors in program logic or sometimes insufficient system resources. So exceptions are not the same as syntax errors, and they cannot be found at the time that you compile your program. So thus far, when we've been debugging and fixing our own and others' code, we've been focusing on syntax errors and logical errors. But you have also, I'm sure, by this point in time, seen exceptions while you were testing or running a program. You know, a pop-up comes up with that red X and it tells you that something has gone wrong. We are going to learn how to handle those so that even if something does go wrong, the user's not going to see that big red X pop up that has a whole bunch of what looks like gibberish if you're not a programmer. So exception handling is the term we use, which refers to object-oriented techniques that we use to manage such errors, such exceptions. Exceptions are objects of the exception class. The way that C# handles these types of errors is that they're built in as a type of class or object. And so we can do something with those errors the same way that we can work with other variables or objects in our C# code. Here's a list of common exceptions. You've probably seen some of these, again, as you've been testing and running some code. And I'm not going to talk about what each of these are. It's a good table to have bookmarked and come back to. I'm sure some of the ones that you've seen already would probably be the format exception, the index out of range exception. Those are some of the big ones. When you're working in chapter 14, you might have seen a io.io exception. Most exceptions come from three classes. There's the parent class, which is the exception class, and then there are two subclasses. There's the system exceptions and the application exceptions. We're just going to be focusing on system exceptions, which are the ones in these tables. Application exceptions are exceptions that can be defined by the programmer. So you can create your own exception for your own particular program. If you can think of something that might go wrong in that program, you can define an application exception and then handle it the same way that you would handle these common system exceptions. We're not going to get into the details and practice of doing that in this video or in this course, but it's a good thing to know. I'd encourage you to look it up later, particularly if you're going to continue programming. But for us, we're just going to focus on those system exceptions and how to deal with them, or using programming language, how to handle them. So again, an exception is a result of an unexpected user action. The example that they use a lot in the textbook is when you inadvertently divide an integer by 0. Another example that you might have seen maybe while working on one of the last few homeworks, if you try and put more elements into an array than there are elements in that array. So if you have an array of size 5 and you try and put 6 things in it, you might see an exception pop up. And if you have seen these exceptions, you will have noticed that your program just terminates suddenly. It doesn't give you any leeway or flexibility. So what we want to do is use object-oriented error handling techniques that give us more elegant or robust or fault-tolerant solutions. So there's two general approaches to handling potential exceptions or logical errors in your code. And we've gone over some examples in the textbook and in our homeworks and our previous video lectures of how you might anticipate a user inputting invalid data and how you might handle that with an if statement. So this is a good thing to do, and it prevents the error, but it's not really exception handling. Exception handling is a term that refers to the techniques that we're going to learn here in the next few minutes using try and catch statements. But of course, using if statements and decision logics and other techniques in your regular code can be a good solution, and it is efficient if you think it will be a frequent problem. So if you anticipate that a user might commonly enter an incorrect number, then you can use your if-else statements like we've been doing. It has little overhead to do that. But if you think that a potential error is going to be rare, then you don't want to use up your system resources checking those if statements every time. If you have a huge program that takes a lot of memory to run, then you don't want to have a lot of if statements checking for errors all the time. The try and catch syntax that we're going to be learning here is much more efficient, makes your applications run faster, and is better for those exceptions that you think will occur once in a while and not frequently. So let me actually jump over to Visual Studio and start building something, and I'll show you both techniques for handling an exception. So I'm going to create a new project, and in this project I'm going to create a list of songs, like a playlist. Now, again, as is normal in these video lectures, this is a very simplified application. I'm not going to actually be building like music and MP3 files into this application. We're just going to have kind of the skeleton of it and use this example to demonstrate error handling or exception handling techniques. So I'm going to call this project playlist, and I'm going to save it in my regular code file on my code folder on my desktop. Now what I'm going to have this application do is it's going to ask how many songs I want on my playlist, and then it's going to prompt me to enter the names of songs to add to that playlist. So we're going to be working and reviewing with arrays again. Okay, so I've got a form here, and I'm going to add a few things to it. I'm going to add a text box, kind of a little bit over on the right. I'm going to call it the number of songs text box. Put a label with it just to give instruction. It says how many songs on your playlist. Okay, so the user is supposed to enter a number here. And I'll add a button. I'll have that button say create, and I will rename it to be the create button. Okay, and then down below, we're going to have the user enter song names one by one. We'll have a text box. I will call it my song text box. Add another button. This one's going to be the add button. And the text will say add to playlist. Okay, and then I'm going to have a label down at the bottom just so that we can see something happening. What's going to happen is when I enter names here and click add on playlist, what I want to happen is I want those song names to be added to an array, a list of songs. So we don't necessarily have to have an output label, but I just like when I press a button to actually see something happen on the screen. So I'm just going to have this label here. I'll call it output label. Okay, and this, I think I've got all the controls I need on my form for this example. So when the user presses the create button, I want something to happen. So I'm going to double click the create button to generate that click event method. What I want to happen is I want to create a list, a playlist. So anytime we have lists, well, not anytime, but most times we have lists, we store them in arrays. So I'm actually going to declare my array up above so that I can refer to it inside of any method. If I create my array in this method, then when I create my method for my other button, I won't be able to refer to that array. So that's why I need to declare array representing a song list. Okay, so this will just be a string array, an array of strings with holding the names of songs. I'll call it playlist. And I won't create it here, I'll just declare it because I don't know what size it's going to be until the user inputs a number. So then down here, I'm going to create the array to be the right size based on the user input. So playlist is going to be an array, a new string array of size whatever the user put in the text box. What did I call that text box? NumSongs text box. Text. Okay, so I've done kind of a lot on one line of code. I could have created a separate variable, you know, like int number of songs, converting what's in that text box. And then here, replace this with number of songs. Okay, that's the more explicit way to do it. It creates an extra variable that we don't need. I'm gonna leave it how we had originally, but if it makes more sense to you to do it on two separate lines, that's fine. You can pause the video and do it that way. Don't forget your semicolons. So basically this takes the user inputs something in the box, we convert that to a variable, to an integer, and then that integer represents the size of this array of strings. So if the user input 3, then we have created an array representing a playlist that has 3 elements so we can store up to 3 names of songs on this playlist. Now, when we want to add something to that playlist, we're going to use our other button, our add button, click event method. And we can add songs to the array as input by the user. So if we were going to add the first element of the array, then we would have playlist subscript 0, and then we would input whatever the user input in that text box into the song text box. Okay, every time we click that button, we don't want it to be saved as the first element in the array. We want it to be saved as the next element in the array. So we're going to create it's not a loop control variable, it's more like a clicking control variable to keep track of how many times the user has clicked the add button. So if they click it once, then whatever is in the text box gets stored in the first element of the array. The second time they click it, the song in the text box gets saved to the second element of the array, and so on. So we just have an integer variable, let's call it add button clicks, and we start it at 0. And then anytime the user clicks on this button, we're going to add whatever's in the text box to that element of our playlist array. So the very first time the user clicks the add button, this variable equals 0, and so this will be 0, and we will add whatever's in the text box to element 0 of our playlist. And then we will increment our click control variable. So add button clicks plus plus. So when we click the button, we add the song to the playlist, and then add button clicks becomes 1 instead of 0. And the next time we click the button, this is 1, so we'll add something to element 1 of the playlist. The next time we click the button, we'll add something to element 2 of the playlist. The next time through, we'll add something to element 3. The next time, element 4. The next time, element 5. So you can see that we might run into a problem here, because if the user keeps clicking the button, then this number is going to get higher than the number of elements we have in our playlist. Let me demonstrate this by running the program. Slow. If you're watching this recorded, you can skip forward a few seconds. Here we go. Okay, so let's say I want to create a playlist that has 3 songs. Okay. When we click the create button, it generates an array, but of course we haven't said to do anything on our actual application. We might want to go back and add just like a message, your playlist has been created, or something like that. Now, if we enter song names, row, row, row your boat. Add it to the playlist. Oh, again, nothing happens on the screen, but it's adding to the array. Let me just actually go back to my code and clean it up a little bit before I do this testing, so that the example makes a little more sense. Okay, so besides adding the song to the array, let's also display the song in the output label. So our output label text, it's starting with a blank text, and we're going to add to it whatever is in the song text box. So we're doing two things with what's in the song text box. We're adding it to the next element of our array, and we're adding it to our output label. And I'm also going to do another little cleanup up here in my create button. Besides creating the array, I also want to tell the user that an array was created. So I'm going to add one more label right here. Maybe move these things down. And this label, I'm going to start it blank, and I'm going to name it create label. Okay. So when we hit that create button, the create label text is going to say playlist, a new blank playlist was created. And then I'll just add, when we click the add button, I'm going to clear the create label text so that a new blank playlist was created doesn't just stay there forever. So when we click the add button, we're just going to clear that label out, have it be an empty string. Okay, now let's try this again. So far in our code, we haven't done any error handling, neither with logic nor with error handling techniques. So we're probably going to run into some exceptions. Okay, here's our form. Let's say I want to create a playlist size 3. Our new blank playlist was created. Now I'm going to enter the songs. Row, row, row your boat. Add it to the playlist. Mary had a little lamb. Oh, I forgot to add these on a new line. Jingle bells. So I've added 3 songs. Now what happens when I add a 4th song? Amazing Grace. There it is. There's the exceptions. These are what we don't want to happen. We're going to learn how to deal with these. You shouldn't let your user see this, because if you've never taken programming before and all you're trying to do is create a playlist and you see this message that says index was outside the bounds of the array, you're going to have no idea what happened. So we're going to deal with this. One way to deal with this is, like I said, using logic. Like if statements. So what we could do is here. Oops. We could put, we could check a condition if the number of times a button has been, the add button has been clicked is greater than or equal to the size of our array. So if we have created a playlist of size 3, but we're clicking on the button a 4th time, then we could put an error message. We can just stick it in that create label text. Your playlist is full. Otherwise, we do our previous code and add it to the array. Whoops, I'd probably also want to, okay, let me just put this comment went with this line of code, so I'm going to keep that together. Here what we're doing is checking if the user clicked more times than the size of the array. If they did, then we just do an error message. If they didn't, if all is good, valid input, then we execute what's in the else statements and we add the songs to the array and put them in the label as we previously had in our code. Okay, when I was testing this, I noticed that I was just adding one song right after another with no spaces or anything. So I'm going to add a new line every time I add something to that label. Now it should work. How many songs on your playlist? 3. Okay, row your boat. Go tell it on the mountain. Danny boy. Mary had a little lamb. It says your playlist is full. So we've corrected that error. We don't see that giant red X popping up. And I will just note that if we create a new playlist, say we create a playlist of size 5, we've actually created a brand new array. This is just reviewing array concepts. Now our array is empty. Even though these songs are still in the label, there is nothing in our array. So what we would want to do is when we click on the create button, we want to make sure that this song label gets reset to be blank. And we also want to reset the number of times we clicked our add button back to 0, because we just want to keep track of how many times we've clicked this button on each playlist that we create. So back in my code, I'm going to do those two things. So when I click that create button, I'm going to reset the song list label. What was that label called? Output label. Output label text is blank. So we reset it when we click that create button. and our add button counter. So this, when we declare this variable, we should actually move this toward the beginning. It's good practice to declare all your variables at the top before, and then put the methods that you created down below your variable declarations. So here we reset the output label, and we reset the add button clicks counter to 0. Because when we click the create button, that represents creating a brand new empty array. Okay, so we've used logic to deal with that exception. And all the way through this example, we still have yet to demonstrate actual C# exception handling techniques. This is a way to use decision logic. As I mentioned, if you think this is something that's going to happen a lot, that a user is going to keep adding songs more than the number of songs they've indicated, then you could do it this way. But we're going to examine a different way to handle this. So if you want to keep a copy of this code using the if-else logic to check for that invalid input, go ahead and pause the video, create a copy of your project folder, and then come back to this video where I'm going to take out this if-else decision structure, and we're going to approach this problem in a new way. We're going to handle the exception using the built-in C# exception handling syntax. So I'm going to delete, well, first of all, I'm going to delete the else. Don't forget to keep your curly braces consistent. That can really mess you up. Okay, so these are no longer, these lines of code where we added songs to the playlist and to the label are no longer within a decision structure. They're no longer in the the else statement. And now I'm going to delete out this if statement. I'm going to put this in a comment for now because we will use that in a little later. I'll show you where to use it if we're not using if-else logic. Just fix my indenting here. Okay, so now we're kind of back to our original code of just adding the songs to the playlist and not handling the exceptions. So now in this version of the code, if the user adds too many songs, they're going to get that red X exception window that we're trying to avoid. So that was a very long way to say that there is the traditional if-else way to handle potential errors, or there is the object-oriented error handling methods, which utilize the terms try, throw, and catch. So you try a procedure that you think may not work correctly, and the terminology that we use is that a method throws an exception. Okay, so throw isn't a keyword that, well, it is a keyword. We're not going to use it in our simple examples, but the word throw is just the term that when you see an exception happen, that means that the application is throwing an exception. And so what we need to do is write some code that catches that exception that the application threw. So it's like a metaphor of throwing and catching. So the keywords that we actually use are the try keyword and the catch keyword. So we try a procedure. If the application throws an exception, then we specify what we do when we catch that exception. Here's a simple, straightforward example. You try, you can put any number of statements inside of this try block. So just the keyword try, nothing in parentheses, and then curly braces, and any code that you want to try can go in there. And then directly after the braces, you have the catch keyword, and then you specify an exception. And inside those curly braces, you put what you want to happen if that exception occurs. So in our example, I'll show you how to do this. We would try adding songs to the playlist, and then if the user accidentally adds too many, then the application will throw an exception. And so we will catch that exception, and here we'll specify what we do about it. Here is where we would put that error message like I had before inside my if block. Okay. And then after the try and catch, anything after that just executes normally. So that's the beauty of try and catch, is when the application throws an exception, it doesn't terminate your program. It doesn't force you to quit. It just does whatever you put inside your catch statement, and then it continues executing the code as if nothing happened. What you put inside of the parentheses for your catch keyword is you put the exception type, and then you give it a name, almost like you're declaring a variable. So the types of exceptions, these are the exceptions that were listed in that table. So for example, the index out of bounds exception, the format exception, those exceptions refer to different things. And then this, you just give it a name. It doesn't matter what you call it. So let me go back to my code. And let's actually run this again without the exception handling. And this is actually what I often do when I'm trying to code my try-catch statements, is I go in and I test my application knowing that it's going to create an error, and I purposely make the application throw an exception. So here I'll just put 2, and I'll put 2 songs, row, row, row. And Mary had a little lamb. And if I try to add We Will Rock You, I should see an exception. Okay, now I did this on purpose because I want to see what type of exception the application is throwing so that I can catch that type of exception. So if I click on details, it tells me right here, system.index out of range exception. So I could even copy and paste that. That is the type of exception that I want to catch. So now, what I want to do is this stuff that previously I had inside of an else statement, I'm going to put it inside of a try block. Okay, so I want C# to try and run this code, knowing that there might be some exception occur. And in this case, an index out of bounds. Is that what it's called? I always forget. It's such a long name. Index out of range exception. And then I want to specify, it's giving me an error because for every time you have a try, you have to have at least one catch. Okay, so inside the parentheses, what I want to put is first the type of exception that I'm catching. So in this case, it's an index out of range exception. So I'm specifically telling C# the type of exception that I'm expecting might happen is an index out of range exception, meaning the user trying to add something to an array when an array is not big enough. So when that type of error happens, and then I just give it a name, it doesn't matter what you call it. Yeah, I don't know. Out of range. It doesn't matter. You're just making up a name. It's like you're declaring a variable. You're declaring an instance of an index out of range exception class. You're creating an index out of range exception object. So now in our catch statement is what we want to happen if this occurs. So it's analogous to what we had inside of our if block before. So when we did the if else, the invalid input that we included in our, or excuse me, the response to the invalid input that we put in our if block is what we would put in our catch block. Okay, so let's test this. So I just want one song on my playlist to make this example quicker, row, row, row. And then if I add another song, yep, it just tells me my playlist is full. So we've handled the exception using built-in error handling techniques. Okay, what's something else that might go wrong here? This is the fun part to me about programming, is once you program something, opening it up and trying to see if you can break it. Do as many silly, crazy things as you think could possibly go wrong. And anytime you see that red X exception pop up, you see what type of exception it is, and you go back to your code and you handle it using try catch. So let's say a user accidentally types in words here. There's another exception. This one is a format exception, which is quite common. It's when you're expecting one data type and you find another one. So in this case, we were expecting a number, but the user input a string, so we have a format exception. So we can handle that in our code. So where is the point in our code where that exception might happen? Well, it's going to happen right here where we're trying to convert the user input to an integer. If the user inputs letters here, this code is what is throwing the exception. So this is what we want to put inside of our try block. And in fact, we also want to put this inside of our try block because we only want that label to be updated if this executes correctly. Okay. Now, we're going to try and catch a format exception, and I'll just call it FE. And there, in that case, we can have our label, instead of saying a new blank playlist was created, we can have it say, please enter a valid number. So now if we run this application, here, if we type in 1, it will give us that error message. So now we're never seeing any red X's pop up. Okay. Now, the exception class, or any object that is created from an exception class, has a ToString method and a message property built into them. So those can provide descriptive error messages to the user that give them precise information. So the ToString method with the parentheses because it's a method, or the message property, which has no parentheses because it's not a method. Those are built in to exception objects. So in our example, we created our own type of error message. But what you could alternatively do, instead of creating your own message, is you could type the name of the exception. See, we named this exception FE, and then dot to, let's start with message. And that is a string that you can save to a label. So I'll show you what happens when we code it that way. So here, if we don't have a number in there, then it puts the text generated by C#. The format exception message is always input string was not in a correct format. Okay, for normal people, that still might not be a great message because people don't usually think of strings as text, but it is an option that you have to use that message property. And then using the ToString method here instead does a similar thing. Except it gives like the full programming error stuff. So this is even less useful. So one option for your error message is to display all this using the exception object name dot ToString. A more useful thing is the exception object name dot message. And probably even more useful than that is if you can create your own error message to help the user. Okay. Whoops. Okay, a couple more things. You can place as many statements as you need within a try block, but only the first one generates an exception. But you can put multiple catch blocks following one single try block. And what the application just, when it throws the exception, it goes through the catch blocks and searches for the right type of exception that occurred that matches what happened. Okay, so here in the example from the textbook, there are two different things that could go wrong in this try statement. Either one thing that could go wrong is the user could divide by 0. Another thing that could go wrong is that you have a number that's more than the number of elements in the array, just like the error that we handled in our example. So there's two different things that could go wrong in this try statement, and so the programmer has added two separate catch statements. So if the error is a divide by 0, then the application jumps down and does what's in here. If the error is the array error, then it jumps down and does what is in the catch block down here. Okay, it is possible, but strongly discouraged, to use just the general exception class to catch any type of error. Now, I showed you how to catch specific types of errors like index out of range exception, format exception. If you just in your catch statement type exception error, then that catches any type of exception that you might face. So here in this same example, whether it's the index out of range or the divide by 0 error, no matter what happens, it will always jump to this single catch block. That's allowed, but it's really not as secure. You run into some security issues with your applications, and it's discouraged to do it this way, but it is a possibility. All right, so you have one try block followed by one or more catch blocks. You can also optionally include a finally block, which performs things at the end of a try or catch sequence. So it executes whether the try block identifies any exceptions or not. So most of the time, things that you want to happen after your try catch block, you just put outside of the try catch blocks. You don't necessarily have to put it in a finally block. But there are a few rare times when you might need to use a finally block, and I think the textbook does a good job at explaining some of those instances. Probably for the assignments and projects in this class, you're certainly welcome to use a finally block, but you can get full credit on everything without using a finally block. So here's the general format. Like I said, you have your try block, one or more catch blocks, and then a finally block, just the finally keyword with curly braces. And whatever's in the finally block happens whether or not an exception occurred. So one example that the textbook uses is closing files. So maybe you're trying to open and read files using the concepts we learned in chapter 14. Some I/O exception occurs, but you want to make sure that the file is closed. If you remember your streamreader.close or streamwriter.close and your file stream.close, those are good statements to have in a finally block because you want those to happen no matter what. Okay, a few more terms just to be familiar with. We're not going to quiz or test you on these. You don't need to know them for your assignments in this class, but it's common terminology. If you're going to continue programming, you should be familiar with these terms. The call stack is the memory location where the computer stores the list of locations, and if a method throws an exception and does not catch it, then the exception is thrown into the next method up the call stack, and that's called propagating the exception. So if you're new to programming, these are very weird and strange terms, and what it says on this statement is probably sounds like a bunch of gibberish to you, and that's okay. If you want to know more, then you can go and do further research or look more in the textbook and get a more clear explanation of these terms. Call stack has a stack trace property. An exception has a stack trace property so that you can examine the call stack and determine the location of an exception. So if your job is to debug other people's code, that's when you really need to know about call stacks and stack trace properties. And finally, I've put a slide in here just to remind you that you can create your own exception classes. The textbook does talk about doing that. In this class, we're not going to go into detail on that. This example shows that if you are creating an application specific to a bank, maybe one thing that you'll know is that you're never going to have a negative bank balance. So you can create an exception class for what happens when you have a negative balance, which isn't a standard system exception that we deal with. If you would like to pursue this, you're going to need to learn more about classes and objects, which is in chapter 9 of the textbook. We also don't go into great detail in this class, but that's just so you know, so you have reference to learn more. All right, go out there and debug and handle all your exceptions.